My talk today is about code quality, so I hope that it will be interesting to a lot of you. Briefly about me, my background is in computer science. For the past 10 years, my focus has been on native iOS development. In this time, I worked on projects for retail banking as well as online trading. And so these were white label projects. And so a lot of the topics that I'll share with you came out of this experience. So the main question I want to answer is how we can improve code quality. And so the first thing I'll talk about is the expression problem. I'll give you two examples to demonstrate. So consider this implementation of regular polygons. So assume that I want to work with polygons in my app. So I've defined a protocol polygon and I have a struct for square and rectangle. So pretty reasonable, I think. If I want to extend it with more shapes, which is probably natural, it is very easy, right? So I just create another struct that conforms to the protocol, very easy. But the thing is that if I want to add more functions, things become a bit more complex. So in this case, I need to make changes in each of the structs that I've defined. So basically, all the existing code is affected. If the function that I'm adding is more generic, I might be able to use protocol extensions, especially in Swift. There's also a similar construct in Kotlin. And so in this way, I can avoid changing all of the structs that I've defined so far. I can implement polygons also in another way. So here I've defined an enum. And so instead of structs, I have cases for square, for rectangle, and I have the same functions, right? So the functionality is exactly the same as in the previous example. If I want to add more functions here, it's actually easy. So I can have an extension on the enum. But here, if I want to add more shapes, then we run into a bit of a problem maybe, because again, I need to make changes in all of my existing implementation, and well, this might not always be possible or desirable. So basically, I'm in the opposite situation compared to the previous example. So that's the expression problem. And the question probably is, do we have a solution for this? So obviously with protocol extensions, I might be able to avoid making cross-cutting changes, but it might not always work. And yeah, so the solution here is to basically, we need to think carefully about the types and the functions that we implement. And we need to consider the future extensibility that we might need. Okay, so I will switch gears a bit now and we'll talk about cooking. I hope that you're not hungry yet. So if you're not hungry, probably after that. But so this is the recipe for pancakes in this case, and yeah, like every other recipe, we have some directions and we have a list of ingredients, right? But yeah, because I'm better at programming, we're not going to cook pancakes. We'll write a program that does the cooking. So this is a typical implementation. of how such a program might look like. And yeah, so for us as developers, there are a few important things here, or at least a few things that we can note. So we have some objects that are being mutated. There are also some implicit dependencies between the function calls. Obviously, if I call this function in a different order, I might not get a pancake in the end. Might be something different. It's also a bit unclear if all of these operations will finish immediately, or maybe some of them are blocking, and so maybe I need to wait for the pan to heat up, for example. And also, there's no error checking, right? So probably some of these functions could fail, and so in this case, I don't have any error handling for this. So the question now is, can we solve these problems? So I think to solve this, it's useful to think of this process in terms of data flow. And so the way we'll start is by listing the most important ingredients. And so in the first step, what I need to do is to sieve the flour. So I'm going to create a sieve function for that. Then in the second step, the output of the sieve function basically is the input of the stir function, and we also add salt. And then in step 3, we need to implement the beat function, and it also takes as input the result from the previous ones. And meanwhile, we can also, in parallel, we can also call the melt function for the butter, and this could be done in parallel, right? I think you get the idea here. So I think it helps to visualize the process in this way, and the benefit is also that it becomes clear if any of these functions fail. So if the beat function returns an error, then I know that all the input that went into it needs to be processed again. And at the same time, I know that, for example, the melt output is not affected. So using this idea, we could rewrite our pancake cooking program like this. So I think the structure is a bit improved, and really we can do some basic checking whether we're doing the correct recipe just by reading the functions. But yeah, so in order for this approach to work, obviously all of these functions and all of these types need to be reusable. As you can see there, I have the beat function taking several different parameters in some of the calls. Also the stir function. So basically, they should be able to work with all the types that I have available. What is the answer to the question then? Yeah, basically, we need to write reusable and easily extensible code. The next question then is, well, how can we actually do that, and what code is reusable, right? Probably a lot of you have played with Lego, or at least you have some idea, right? And I think Lego is a great example of kind of a system that has reusable components. Because even with a small set of bricks, I can really combine them in a lot of different ways. But in order for us to be able to create a similarly designed software system, what we need to think about is cohesion and coupling. These are very important things. I think it's best to try to visualize them on this kind of graph. And so in the lower part, we have cases with low cohesion. And on the left-hand side, we have cases where we have low coupling. If there's lack of cohesion in the code, basically it turns into a sort of a puzzle that we need to solve. Because in one instance, the components that we have or the classes that we have they will only work in a certain specific way. And if we don't use them in this particular way, then things will not work. So usually low cohesion is caused by large inheritance hierarchies or just some overuse of design patterns. Basically, the well-designed system tends to have high cohesion and low coupling. which is the Lego example. So it's high cohesion within a component and low coupling between individual components. This is actually kind of a real life example that one of the colleagues encountered. This what happens when cohesion is lost. Basically, we have a bunch of objects that individually they're not reusable because each of them depends on every other one. So we're kind of stuck in this situation. So, okay, the big question, right? Like, what code can be reused? So from my point of view, it comes down to these two questions. For the same set of data, usually we can use it for different purposes. And usually for some behavior, it can be applied in different contexts. I think the example with data is probably more clear. For the behavior, just think of the cooking functions that we defined earlier. If we have objects that can serve multiple purposes, we should extract them into domain logic. With regards to behavior, if it can be applied in a different context, then we need to isolate it in what I want to call interaction logic. In some places, they call this kind of logic services, like as a separate layer. Well, it depends also if it's a GUI application or maybe just a backend. I find this term more appropriate. And so in the domain logic, we need to aim for informational cohesion, right? Because we'll have some domain objects. We need to model these carefully according to the business domain. In the interaction logic, we need to try to achieve functional cohesion. A lot of software applications usually have some kind of an algorithm that will go there. Or if it's a UI application, there will be a lot of UI logic there, probably. These things need to be separate because achieving both informational and functional cohesion in the same component just doesn't work. So what about code that cannot be reused, right? It could often be the case, maybe even most of the time. So in this situation, the code is basically application logic. So it implements a specific use case, just like the pancake recipe. Well, I probably cannot make changes there because, I don't know, it will not be pancakes if I change it. But the thing is that by extracting domain and interaction logic properly, this will keep the application logic cohesive. So normally the application logic will have a bit weaker cohesion because of, because it just implements very particular use cases from the business domain. And again, try to make this analogy with the recipe. So of course things could go wrong. I mean, this is not like a silver bullet. So we need to consider when we try to achieve reuse, we need to consider carefully the specifics of the project and of the business domain, and we need to avoid. We need to be careful what abstractions we create, and to avoid too many shared types, because usually these things bring bad implementation eventually. And so in my last project, we were actually able to apply these ideas into a lot of to a large part of the mobile code base. So it was a lot of the screens were refactored, and we also made UI improvements, and were able to add more animations to the UI. So all of this code actually served as a starting point for the current project that I'm working on. So this is the book that discusses a lot of the points that I raised. So I could say that the book is about functional programming, and because the examples are using a functional language, but there are a lot more ideas in there that could be applied even if we're not using F#, for example, which is the example language. I highly recommend the book. There are also a few talks that were done by the same author. which are on YouTube. So if you scan the code, you will see a few links there. And yeah, that's what I want to share with you. Maybe some of you have questions or comments.
First, applause for the presentation.